For section 5.3, we will go over the addition rule and multiplication rule for probability. For addition rule, when it is mutually exclusive, that means there will be no overlap, so I'll just add the probabilities together. When they are not mutually exclusive, that means that they will have an overlapping section. So I do probability plus the probability minus where they overlap. When multiplying, when it's independent, and it says and, we multiply our probability. When it's dependent, when it will affect our probability the next time we roll or draw something, we have to manipulate our second probability to fit it. Conditional is when we have a specific group, so it zones in on a specific section of our sample, and then we pick from that sample group. For question A, it says two events are mutually exclusive if they cannot occur at the same time. So a single-sided die is rolled, 6 sides. What is the probability of rolling a 2? There's only 1 2 out of the 6. Or means I add. Probability of rolling a 5 is 1 out of 6 as well. When I add them together, that makes 2 out of 6, which will reduce to 1/3. What is the probability of drawing an ace? There are 4 aces out of the 52 cards, or means I add kings. There are 4 kings out of a deck. When I combine those together, I get a total of 8 out of 52. Reduce. That would be 4/26, 2/13. Won't reduce anymore. Question B, two events are not mutually exclusive if overlap or an intersection occurs. What is the probability of drawing a heart? There are 13 hearts. Or means I add a king. There are 4 kings. But when I count the hearts and the kings, I have to get rid of 1 card because there is a king of hearts. That is the intersection that I have to subtract and make go away because I double counted it on accident. 13 plus 4 is 17. Take away 1 is 16 out of 52. I reduce it. That would be 8 out of 26, 4 out of 13. Can't reduce anymore. Question C, determine if the following question is mutually exclusive. So I'm going to go through. Mutually exclusive means that they cannot occur at the same time. A single card is chosen from a deck of 52. What is the probability of a king, 4 kings, or a club? There are 13 clubs. Now I have to ask myself, is there overlap? Is there a king of clubs? Yes, there is. So I have to take away 1 card because I double counted it. That would make 4, 5, 6, 17. Minus 1 is 16 out of 52, which we have reduced before. It became 4/13. Now we have to decide, because there was this overlap section, that means that it is not mutually exclusive. Question D. Two events are independent if the occurrence of one does not change the probability of the other occurring. What is the probability of rolling a 2 on a die? 1 out of 6. And means I multiply. Flipping a head on a coin. There's one head out of heads and tails. When I multiply these, 1 times 1 is 1. 6 times 2 is 12. Or we add and we multiply. A jar contains 3 red, 2 blue, 6 yellow. A marble is chosen at random. After replacing it, a second marble is chosen. What is the probability of choosing a green? Green. I need to edit. There's no green, so it would make it 0. Okay, we're going to edit. We're going to make this a red and yellow. Okay. Probability of picking a red would be 3 out of 3, 4, 5, 6, 7, 8, 9, 10, 11. And means that I multiply. You can use the little multiply sign or a dot. Then a yellow marble. So I picked a marble out, I put it back in. My probability of getting a yellow is 6 out of the total 11 because the marble was replaced. That would give me 3 times 6 is 18 over 11 times 11, 121. If the occurrence of one event does affect the probability of the other occurring, then the events are dependent. They depend on each other. The probability of an event occurring given another one has already occurred is conditional. A card is chosen at random from a standard deck of playing cards. Without replacing it, a second card is chosen. What is the probability that the first one is a queen? 4 queens out of 52, and multiply. The second card is a jack. Now there are 4 jacks, but I have a queen that I have taken out that is still sitting in my hand, which means there are only now 51 cards. 4 times 4, 16. 52 times 51. Then I reduce, which will give me 4 over 663. And if you are struggling, all of the calculations you can do on your calculator, and it will reduce for you. Okay, what is the probability that the first card is a queen? 4 out of 52. And multiply. The second card is a queen again. Well, if I have a queen in my hand, that means there are only 3 queens left. And if I have a queen in my hand, that means there's no longer 52 cards, but there are now 51 cards. 3 times 4 is 12. 52 times 51. I then reduce it and get 1 over 221. A jar contains 22 red marbles numbered 1 to 22. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Then there are 34 blue marbles. The blue marbles are numbered 1 through 34. Okay, 22 red, 34 blue. A marble is drawn at random from the jar. Find the probability of the given events. Please enter reduced fraction. Okay, what is the probability that the marble is blue? Oh, I want to find my total. I'm going to write my total up here. 22 plus 34, 56. So total blue, there are 34 blue out of the 56. I then reduce it, which gives me 17 out of 28. The marble is an odd. All right, marble is an odd number. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 odd numbers. 22 total, 11 of them are odd. Then I count these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. If you notice, half of them are odd. That means I would have 28 over the 56 total, which would reduce to half. The marble is red or odd. Red marbles, I have a total of 22, or means I add. Odd numbers, I have my odd right here, there were 28. But I have to subtract the overlap, so I'm going to look for my red odds. My red odds, I counted 11 double because I counted my red, my odd. I have to minus the overlap. That would give me 22 plus 28 minus 11 is 39. I would then reduce it. 39 over 56. That won't reduce. That's my final answer. The marble is blue or even. I have 34 blue even numbers. Even, I have 28 out of 56. Half of my numbers are even. Then I subtract the overlap. So blue even. I look here. How many are blue and even? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. When I do 34 plus 28, take away the 17 that overlapped, that gives me 44 over 56, which will reduce to 11 over 14. The marble is blue and even. So my probability of getting a blue marble is 34 out of 56, and means that I multiply out of my blue, how many of them are even? There are 17 even out of the 34. That will cross out and leave me with 17 out of 56. If you want to, you could just count up how many marbles are blue and even. So I look at here, 17 are blue and even, 17 out of the total. Suppose that 15% of people own a motorcycle. If you pick 2 people at random, what is the probability that they both own a motorcycle? 15% own a motorcycle. So I would have 0.15 multiplied by 0.15. That's my probability for the first person, probability for the second person. 2 random people. I would multiply these together. 0.15 times 0.15. Whoops, get rid of the negative on there. 0.15 times 0.15. 0.0225. That means 2.25%. What would the probability be if randomly selecting 3 people? If I select 3 people, that's my probability for the first, second, third. 0.15% times 15% times 15%. Move the decimal twice. That is 0.3375%. Very unlikely. ACT questions. If the probability of event A is PA and the probability of event B is PB, what is the probability that both A and B would occur? And means multiply. If Wayne considers the letter Y to be a vowel, but Kristen does not, thinking that there are only 5 vowels, by what % is the probability that a randomly selected letter out of the 26-letter alphabet will be a vowel greater in Wayne's opinion than in Kristen's? In Wayne's opinion, there are 6. In Kristen's opinion, there are 5. 6 divided by 5 is 1.2. which is 120%, which means it's 20% above Kristen's. A bag contains 11 purple marbles, 11 yellow, 11 red, and 11 black. That's 44. The first 4 marbles removed are all purple. That means I had 11 out of 44. Then I had 10 out of 43. Then I had 9 out of 42. 8 out of 41. Those are the first 4 purple marbles removed. What is the probability that the fifth marble removed will also be purple? So then if I do purple again, I have 8 in my hand. That means that there are 7 left out of the 40.